Okay, for today, we started with this one, and I think you know that these guys can cancel. But I did remind you, as I was giving you the directions, to also say, but x cannot equal 4. Because see, if it did, it would make the bottom part 0. And in the original problem, that would kill the function. So we have to note that. All right, is there anything else that would cancel or simplify? Yes. This x here, and there's x right there. So this x can cancel, and instead of x, I would now have only 2 of them left. And then the 3/6, of course, is 1/2. Now, if you don't want to do it that way, the way I like to show is 6 is like 3 times 2, and then just cancel the 3's. All right, so your final answer on this one is nothing else on the top except a 1. I better include the 1 then. No parentheses needed. And then the 2x squared, and that's it. There's my equation. But x cannot equal 4, and what else? X cannot equal 0, because if it does, then you're dividing 1 divided by 0, which won't exist. All right, cool. There's kind of a reminder where we were at. Now, where are we going now? Now we're going to take what are called rational expressions. This is a rational expression. And then this is another rational expression. And then we're going to add them together, but we're going to need to get common denominators. Because see, you can't just leave it like this. It's got to all go together. You have to actually add them. So I want you to write that one down. Well, let's talk about common denominators. What is the denominator on the one that doesn't seem like it has a denominator? Well, of course, it's a 1. So I just put over 1. Then, what you do to get common denominators is you figure out, I would just keep it simple. I would figure out, can I just multiply these two together to get a common denominator? See, I know this might look really complicated, so let's go off to a much simpler one. Don't even write this down, just listen for a minute. If I was adding these two, they don't have a common denominator, right? But couldn't I just multiply their denominators and use 10 as a common denominator? Yeah, you can always do that. All right, so now, is there times when it would be smarter to do it differently? Yes, let me give you this example. Do you get if I had a 2 and a 10, 20 would work as a common denominator, right? But if I factor my 10, because my favorite saying, if you can factor it, you should, it's really like a 2 times a 5, right? Then do you get they both have a 2 in the denominator? So I don't need to multiply both denominators. I could just multiply this one by 5 and 5. You see what I did there? I got a common denominator without having to use 20 as the denominator. I factored it, and I figured out, oh, they both already have a 2. I really just needed a 5 over here. All right, so that's, I know you know this with regular numbers. If I use 10 and 5 as my denominators, I could use 50. It would work. But the numbers are going to be really, really big. Would you please do that process I just showed you and factor the 10 and then give them a common denominator in a little more intelligent way? Instead of just using 50, which would work, but you have huge numbers you got to reduce, you make the 10 into 5 times 2. And that'll make you realize, well, to get a common denominator, what do I really have to do then to get a common denominator?
Take times 5 at the top.
If I times by 5, do I have a common denominator now? Nope. The point is to get these guys the same. This and this. They're not the same right now. Joey, do you know what to do?
Multiply the other side by 2.
Yes. If I multiply by 2 right there, is that legal to just multiply that by 2? No, but if I multiply this and this by 2, is that legal? Yes, and the reason is because I technically just multiplied it by 1. All right, and now, look at it. Does it have a common denominator now? Yeah. So, and that's smarter than using 50 for a common denominator, isn't it? 50 would have worked. Could have multiplied both of them, but this is smarter because now the denominator is a lot smaller and it's the same. All right, now given all that I just said, we're going back to this problem. Is there any way to factor either of the things that are circled in yellow? No, unless you're going to do something weird like factor out a 1. You can always do that, but that doesn't really help. So then, what could I multiply this one by so that they would have a common denominator? Yes?
X plus 3.
X plus 3. See, if I multiply by x plus 3 here and here, just look at it. Don't they have the same denominator now? Yeah, they got a common denominator. All right, so that's the point of today, is to get a common denominator. Now, there is a little bit of work after that. The denominator is x plus 3. And if you're like, but what about 1 times? You know that 1 times x plus 3 is x plus 3, right? So I'm going to just make it a little simpler. And then what's the top? 1 plus all that. And so what I'd do is actually multiply it all out and then see if it factors. So 2x times x would make 2x squared. And I got this 1, so I'm going to go put 1. Let me erase this to get a little bit more room on top of my top of my fraction bar there. So I just copied the 1 down from here, and then I have a 2x times x, which is going to give me a 2x squared, and a 2x times 3, which is going to give me a 6x. And then that 1 feels weird because it's out in front. I'm going to put the plus 1 at the end. And then what question do you think you should always ask yourself at the end? Can I factor it? Exactly. Because see, if this top one would factor, which it doesn't, but if it would, then it might cancel this x plus 3 off. But the top does not factor. I've done enough factoring to be able to tell that pretty quick, that won't factor. If it would, you'd want to. All right, so I'm going to give you like the simplest one that exists in this world. 1 over x plus 3. Get them to have a common denominator, and then actually add them together. This one I want you to copy down and do. Noah, what's the denominator of the 3?
1.
Yes. Seb, what should I do to, well, I could do something to the right side to make it so they'll have a common denominator. Do you know what?
Multiply the numerator by x.
Multiply by x, multiply by x. Very nice. Then you just look at it and you go, are the denominators the same now? Yeah, they are. So then, what's left? If you wrote 1 plus 3x, you do need to be reminded that the variables are supposed to go in descending order. Like if you had an x squared, it would be first. If you had a regular x, it'd be second. And that 1 is a constant. It's supposed to be last. So I hope most of you probably knew to put it as 3x plus 1. All right. All right. You are later than 10 minutes, unfortunately, youngster. So, all right. So this next one, we're going to go 1 over x plus 3. That doesn't have to be in parentheses, but I hope you know there could be parentheses there. Plus 1 over x plus 4. I remember when I looked at this, I was like, is there any way I can just like add 1 to the denominator of the left side and then it would be x plus 4? Nope. You have to multiply by stuff. You can't just like add 1 down here. There's no such thing as adding 1 on top and adding 1 on the bottom. That's not a thing. You can multiply by something on the top and the bottom. So, at the beginning of the problem, you should ask yourself, is there any way to factor it? At the end of the problem, you should ask yourself, is there any way to factor it? And there's no way to factor it. So, some of you wouldn't need my help on this, but I think some of you could use this advice. Multiply by something on the one side and something else on the other side, and you'll get a common denominator. And by the way, this is that slow way that always will work. You multiply the two denominators together. That will become your common denominator. Like, when it was 1 over 10 plus 1 over 5, and I said you could use 50, but there'd be a smarter way. But 50 would always work. If you multiply them together, that will always give you a common denominator. It's just sometimes the slow way. In this case, I hope you have figured out that you'd multiply this one by x plus 3 and this one by x plus 4. And now you've got a common denominator. Of course, I have to do it here also. And I have to match what's on the bottom here also. Now, it's not even super easy from here. It's super easy to tell a denominator, and I know some of you are going to think you should multiply it out. But then, at the end, aren't I going to say, if you can factor it, you should? So be smart and leave it factored. Because otherwise, if you multiply it all the way out, then you got to factor it back. So then what's left on the top? X plus 4 times 1 is still x plus 4. X plus 4 plus that. X plus 3. I hope your instincts kick in and go, I can add some of those together. Sadly, some kids think x squared, not x squared. What is it? 2x. And these two together, plus 7. Final answer, 2x plus 7 over, and again, I could have multiplied that out, but then I just have to factor it again, so I'm going to leave it factored. And then you ask yourself, is there any other way to factor it? Well, this top cannot be factored because if it had been a 2x plus 14 or something, then I could have factored it if there had been a 2 in both parts. All right, there's your answer. That is a typical question. That's all I had to get across today, is can you get a common denominator? All right, so we're going to practice that a little bit. And then for the last 20 minutes of class, you're going to actually, I'm going to try to devote 30 minutes to this. We're going to take another basics test. Here's a couple things you'll want to know from that basics test. Do you remember how to handle a fraction over a fraction? See, if you don't, when we get to this later, you're going to get tripped up on a test. That's coming on a future test. Do you remember how to do it? Let's write off the silver 20. And some of you might be like, yeah, I got 19 before. Well, you might have forgotten some things. Just like a basketball coach doesn't say, well, you were getting 9 out of 10 free throws early in the season, so we're not going to shoot any more free throws for the whole rest of the year. That'd be dumb. Got to go back and shoot some more free throws. You times this by 5/3. Does that ring a bell? All right. And then it is as simple as 5 over 12. You just multiply across the top and the bottom. There's a few other little basics on there. And I want to take a minute so that you can look at those. So I'm going to pause for a minute, and I'm going to hand out a basic sheet. And then you'll be able to take a look at it and see if you can find any spots that you're still weak on. All right, so the students have looked at this sheet. They're trying to find out of the 20 basics if there's any in there that they're a little concerned about getting wrong. And now, I am pairing row 1 and 2 straight across, row 3 and 4 straight across. You guys know how I pair you guys on this side of the room. And I want you to actually slide 6 inches apart and talk for a few minutes about how do you do this one? How do you do that one? If both of you are stuck on a problem, I will walk over. You just got to raise your hand. I'll show you both how to do it. Next, I'd like you to find the worksheet that is assigned for today. problems you can skip and which ones you should do. Find the worksheet, it's super easy, and I'm cutting it in half because we're going to spend the rest of the hour doing the silver 20. All right, so find that worksheet, and what we're doing is the odd problems. So on the worksheet, you can just write odds at the top, or you, of course, could cross off 2, 4, 6, 8, 10, etc. So we're just doing the odds. Would you read me number 1?
Number 1 is 2 over x minus 1 over x plus 3.
All right. Do they have a common denominator? Are the denominators the same right now? No. Can you just add 3 on the top and bottom over here? Is that a legal thing? No, it's not. Got to get that through your head. You can't add on the top and the bottom. That's not a thing. So you go to, can I factor anything? Nope. None of these parts can factor. Since I can't factor, then I just have to multiply this side by something and multiply that side by something. Shaharsh, what should I multiply where? How about on the left side here? What should I multiply here and here? Yep, x plus 3. And on the right side? Just x. And then you stop and look and you go, have I got a common denominator? Yes, I do. And you leave it factored. Remember that factored is the superior form. At the end of the problem, you're going to have to factor it. So leave it factored. And then your only challenge is what's left on top. That part comes out to 2x plus 6. And this part, careful with the minus there, has a minus x. And then, of course, 2x and minus x can combine. Like this and this can go together. And then you get your final answer. All right, you're just doing the odd problems. 1, 3, 5, 7, 9, and 7. Yes,
Would
question?
you want to do like x squared and then plus 3x?
Yeah, if you wanted to multiply it out, but you want to factor it at the end, so you might as well just leave it factored. Just leave it factored. If the top can factor, by the way, which it might. Ooh, let me think about that. No, top can't factor. Once I have 2x minus x, it's just going to be x plus 6, and that's already factored. So, all right. Final answer. 2x and the minus x makes x plus 6. And on the bottom, you leave it factored. And you look, is there anything can cancel? Nope, nothing can cancel, so then you're done. All right, 1, 3, 5, 7, 9, etc. All right, now set that aside and grab your iPad, and on your iPad, get to the, what's it called, Silver 20. And you now need to finish that in class. The only people who can have an exception to that is if you have an IEP or a 504 that gives you extended time, then you do have extended time. But everybody else, you gotta finish that during class. The fastest ever is 4 minutes and 20 seconds. So don't think you have to get it, this is impossible, I can't get this done. You absolutely can. I know you probably won't get 4 minutes and 20 seconds, but a lot of you can get it done in 15 minutes, and I'm giving you about 30. All right, on your mark. Get set. And if you haven't already gone yet. Crap. Oh, I clicked Wednesday. By the way, I'm going to be gone tomorrow. Side note, I have a doctor. They're going to scan some things. I get to be some kind of scan. So anyway, I'll be back on Thursday. I got a good math sub for you. So it's harder work to try to get try to set up the sub ahead of time, but I've got somebody who knows how to do math. And there, it is enabled. And mark it set go. And that's all I got for the video for today.